A queue is a data structure similar to a stack, except that in a queue, the first item inserted is the first one that can be removed. This is what we call FIFO, first in, first out. Stacks, on the other hand, are LIFO data structures, last in, first out. A queue in programming is like a queue or line of people in the real world. People join the line from the back and leave from the front. Queues work exactly the same. Now let's look at a few applications of using queues. We can use queues in situations where we have a resource, and this resource must be shared amongst many consumers. So these consumers should line up and use the resource one by one. Here are a few examples. Printers use queues to manage jobs. It prints these jobs in the order they're submitted. Operating systems use queues to manage processes. So these processes wait in a queue for their turn to run. Web servers also use queues to manage incoming requests. These requests go in a queue and get processed in the order they're received. Another application of queues is in building live support systems. For example, when you have a problem with your web host, you may jump on their website and use the live support. Now, there's someone sitting there responding to people's requests. He or she cannot service everyone at the same time, right? So you have to go in a queue. So there is a resource with many consumers. These consumers get access to the resource based on their position in the queue. These are all examples of using queues. Now let's look at various operations that queues support and their runtime complexities. We have enqueue for adding an item to the back of the queue, dequeue for removing the item at the front of the queue, peek for getting the item at the front without removing it, as well as isEmpty and isFull. Similar to stacks, all these operations run in constant time or OR1 because items are added or removed from the ends, and this is very fast. Next, we're going to look at queue implementations in Java.